Hi, I'm Namita, and let's look at the sentence prediction system part of the TutorBot. As we can say in the interface, uh, when you enter like I want to or and and you can see the suggested sentences after a time. It takes time because it takes count of almost 5 tokens, so it consumes time for generating the predictions. Yeah, as you can see the predictions over here. And let us try another example like I'm very, which is a sentence fragment. Like part of a sentence is given to the tutor bot, and then the predictions are seen both in English and French. As you can see the results over here. So the main working mechanism of this prediction system is like it is a bilingual sentence prediction. That is, it takes both English and French inputs, whichever you want. Like you can either put it in English or in French. At high level, the system takes any sentence fragment and generates contextually relevant completions using a pre-trained language model. And if the input is English, it first translates into French using MariaNMT. We can just look it in the code file over here, which is predict.py. As you can see, it is using Helsinki NLP, which is known as MariaNMT. What does it do is like it is a sequence to sequence encoder decoder architecture, which is used for and which is trained for machine translation. So it first translates if you English sentences into French, and then the main component of this predict.py is French GPT-2 variant. We use specifically GPT-2 because it is fast, although the model is small, and it is mainly trained on French. Uh, it mainly uses causal language model, and it predicts next tokens using autoregressive decoding. And the main components we leveraged here are tokenization. That is, we use the tokenization concept and the positional embedding and self attention to generate grammatically sound and semantically coherent continuations. And also, in order to balance randomness and coherence, we also used top K sampling, nucleus sampling, and temperature scaling, which helps in balancing the output or completions of the text. And then, often after generating the output, in order to convert back it to English, we use another MariaNMT model that is mainly based on subword tokenization, and it uses sentence piece, which is mainly known for its handling of morphologically rich languages. So when you give a complex language, it will be able to handle that case too. And then in order to detect language, like whether the given input language is English or French, it used DeepL's API. And then in this predict.py, we mainly use DeepL's API, Open API, and then Hugging Face library, which is the main, I mean, like from which we got MariaNMT models. And uh, while constructing the predict.py, I got to learn more about the things related to positional embedding and sequence to sequence encoder decoder architecture and tokenization. And I have found the interesting one, which is a probabilistic classification that is used mainly used for language detection. So it has helped me a lot to learn more about NLP models, which I found interesting. Let's look at the next part.